In order to be a dancer or ice skater, you need balance.
Balance is the even distribution of weight that creates zero torque and zero extraneous forces.
Being a figure skater, you need to keep your arms out, perpendicular to body, and parallel to the ice to keep balance.
A dancer needs to keep her chest up and above the rib cage while she turns.
Physics is seen in different aspects of ice skating and dance. It is seen in turns, rolls, and jumps. The physics of each move is different depending on the sport. Ice skating elements work through centripetal force, while dance deals with rotational kinematics.
An axel is one of the beginning steps to harder figure skating jumps. The axel is more difficult than a flip or a lutz, which takes off backwards. The axel takes off forward. The axel starts with the left leg with a semicircle into the middle of the beginning of the jump. The axel is a jump with 1.5 rotations in the air. Skaters take off on the outside edge of the left leg, and the left leg crosses over the right leg. When landing the axel, you land with the right leg and completing the semicircle you started with. For the axel, when I pull in my arms and have my left leg cross over my right leg, I'm increasing angular velocity. A camel spin is when the right leg is at a 90-degree angle to the body. Skaters can balance during the spin because there is zero torque. As I go into the camel spin, my torso leans lower and therefore my right leg helps me balance my body. There are zero extraneous forces. In order to go faster, I put my hands behind my back, decreasing air resistance and conserving angular momentum. The sit spin involves the right leg out in a sitting position, hence the term sit spin. With my hands out, my body is balanced and I can keep rotational inertia. As I begin to stand up for my sit spin, my right leg comes in and I am increasing my angular velocity, which means I rotate faster.
So we know Kathy's inertia is 1/2 mr squared, her mass is 50.8, and her distance is 0.91. This is her distance before when her foot is out. And we know her angular velocity is 2 pi over 0.8. The 0.8 is the time for one rotation, and one rotation is 2 pi radians. And her radius changes at the end of the sit spin to 0.37 meters. So first thing we do is calculate P, which is equal to our angular momentum, which is moment of inertia times angular velocity. This is equal to 1/2 of 50.8 times 0.91 squared multiplied by our 2 pi over 0.8. This is equal to 165.2. Now, we know that if momentum is conserved throughout, then when her radius changes to 0.37 meters, then if our momentum stays the same and we took our radius and we took our inertia and we decreased it, that means we must have increased our angular velocity. This shows how when she brings her foot inward, she starts speeding up. So if we know that 165.2 is maintained, then her moment of inertia is 1/2 50.8 times 0.37 squared times our angular velocity. So we would get 165.2 her angular velocity changes to 47.51. Now we can see how our angular velocity changed from 2 pi over 8, which was 7.85, to 47.51. This shows that as she moved her leg in, her angular velocity increased drastically.
A pirouette is when a dancer positions her leg into the shape of a number 4 and turns while keeping in an upright position. Momentum is created by the dancer's preparation for the turn. As the dancer brings in her arms, the turns become faster. The preparation is in 4th position because the greater surface area between the dancer's feet and her rib cage creates a greater center of gravity to help keep her balance. Also keep balance by spotting. This is when she keeps her eyes on a spot as she turns and whips her head back as her body turns away from the spot. This is something I'm really bad at. We're better. A grand jeté is when a dancer throws her legs 90 degrees with a corresponding high jump. Unlike the pirouette, where the dancer starts with an initial velocity of 0 meters per second, a jeté is usually preceded by a sachet step or glissade. This gives the dancer some initial velocity. Then, there is a plie before the jump, which is when the dancer bends her knees and uses the energy from her push down on the floor to get her body in the air. This portrays Newton's third law, which states that every action has an opposite and equal reaction. The bigger the plie, the larger the jump of the dancer.
So without the plie, Katie's jump was 0.8 meters. So to calculate her initial velocity when she went off the ground, we would do v final squared is equal to v initial squared plus 2a delta x, just like we've done in class. So we know her v final squared is 0 when she's at the very top of her jump. So 0 is equal to v initial squared plus 2 times negative 9.8 times her delta x, which was 0.8 meters. So if we rearrange this, we get v is equal to square root of 2 times 9.8 times 0.8. So v is equal to 3.96 meters per second. Now, without the plie, we know she jumped 3.96 meters per second. So with the plie, she should have gotten some initial velocity that was greater than her final initial velocity. So then we would use the same equation here. We would do v final squared is equal to v initial squared plus 2a delta x. We know her final velocity is 0 because that's when she's at the top. So we know 0 is equal to v initial squared plus 2 times negative 9.8 times her height off the ground was 0.95. 0.95. So then if we rearrange this, we would get v initial is equal to square root 2 times 9.8 times 0.95. And this is equal to 4.6 meters per second. So as you can see, with the plie, she attained greater height, meaning she lifted off the ground with a greater magnitude of velocity, which was 4.6, rather than without the plie, where she jumped off the ground with 3.96.
A tour jeté is a jeté done in all directions and in a circle. It is usually preceded by a chassé. This move can be done because while the dancer is in flight, the only force acting on her is gravity. She can then change directions while jumping, literally switching her thrown out legs in midair. The dancer gets momentum to jump from her arms rather than the plie. Her arms go up at first and then release to her sides. Without the arms, the jeté would not be as high and the direction change could not be completed. A split back is when a dancer rolls over her left shoulder while doing a split with her legs. The dancer must pull forward in order to get momentum so that she does not fall out of the move while she does it.
I'm holding on the rope, got me 10 feet off the ground. I'm hearing what you say, but I'm